Okay, so we're looking for basically the Maclaurin series for cosh x. So if fx equals cosh x, that's equal to e power x plus e power minus x over 2, which is a half ex plus a half e minus x. First derivative would be a half ex minus a half e minus x. And then the second derivative takes us back to the original, plus a half e minus x. By the way, it's actually hyperbolic sine, so we're just switching between the two. So the nth derivative would be hyperbolic sine, or either hyperbolic cosine. It's the sign when n is odd, and when n is even, it's the hyperbolic cosine. So calculating it at 0, we basically get 0 or 1. This is for odd ends, and this one is for even ends. So the Maclaurin series would just be all the evens. So that would just be the sum n from 0 to infinity x power 2n over 2n factorial. Now, the remainder up until the kth term will be less than or equal to m or power k plus 1 over k plus 1 factorial. And this is, we'll do this on the interval minus or to or, where a is 0 here in this question. Now the m will be the maximum on minus or to or for the k plus 1 derivative. Now, the maximum here is 1. It doesn't matter which of the two we have here. The hyperbolic sine and hyperbolic cosine function are both bounded. They're both less than 1. In actually a similar way that sine and cosine are bounded in magnitude by 1. So that means that the remainder will be less than or equal to or k plus 1 over k plus 1 factorial. If we just let n equals k plus 1, this will be equal or n over n factorial. And then this will go to 0 as n goes to infinity. And that was proven around about 22nd of November was a question of the day, that last one here. So yeah, we've proven that on any length of interval minus or to or, the hyperbolic cosine function, its remainder in the Taylor series, will converge to 0, and that's on an arbitrarily large interval. So essentially on the whole real line, essentially.